Hi there. Like I mentioned in class today, there are just a few more details at the bottom of this handout that I wanted to wrap up regarding z-scores. So, having done the calculations and doing the calculations and being able to make comparisons based on z-scores, that's the most important skill. So some follow-up details. Z-scores are a linear transformation of the original data set. So by linear transformation, what I mean is the actual formula for a z-score can be rewritten into the form y equals mx plus b. And this will have some implications later on in the trimester. So take a look at this. Z equals x minus x bar, that quantity divided by the standard deviation. I can rewrite it this way. I could take the deviation of x minus x bar, and instead I could multiply it by 1 over the standard deviation. That would be equivalent. Well, by distributing then, that 1 over the standard deviation is multiplied to the observation x, and then we are subtracting the constant x bar over the standard deviation after I distribute that to both terms. So notice this really is in the form y equals mx plus b. So here is the slope, 1 over the standard deviation, that would be the slope. Our observations value is x, and then plus b, that would be plus the opposite of the mean divided by the standard deviation. So it's much more important at this point that you're able to calculate z-scores. Worrying about the fact that they are a linear transformation, that's something to worry about later on. But again, when we get to that point, it's just a simple reorganization of the original expression for a z-score. So a more useful fact at this point, z-scores have a mean of 0 and a standard deviation of 1. They also have no units. If you watched the previous video, you would have already recognized that z-scores have no units. Understand whatever unit you have for the deviation is the same as the unit for the standard deviation in the denominator, so they will cancel. So there is a formal proof on my Moodle site regarding why z-scores have a mean of 0 and why they have a standard deviation of 1. At this point, I think it would be more useful to actually use our data and do some calculator work to see that same observation. So let me switch to the calculator. I have put our 28 geometry final exam scores into list 1. And so what I'm going to do is run one variable statistics on my list 1. And you know what I'm going to do? I'm actually going to start over here real briefly. And what I'm going to do here on my screen is put the key press history so that you can see exactly the keys that I've pressed to do everything here. So I'm going to start by running my one variable statistics, stat button, calculate menu, one variable statistics. So my data are in list 1, so I'm going to go ahead and calculate that. What's important here is in the calculator, it has stored the mean as 78.8928, etc., and it hasn't rounded. Same thing for the standard deviation. So when I calculate the z-scores, I am going to use the stored means and standard deviations. So I'm going to clear my home screen here, and I'm going to put the z-scores into list 2. So I'm going to start by opening a set of parentheses. My observations are in list 1, so I'll press second 1. Then I need to subtract the mean. But I'm not going to type in the mean as 78.9. Instead, I'm going to call up the stored value of the mean in the calculator. So that's done by pressing the variables button. If you press the down arrow, you can go to the statistics option, option number 5. Notice the mean is option number 2. So I can go down and select option number 2 and press enter. So then understand, I'm taking list 1 and subtracting the mean that was stored when I calculated one variable statistics. I don't have to round it. It would be perfectly fine to round it, but we will get much more exact results here by not rounding. So that's my deviations. Then I need to divide by the standard deviation. And again, that was stored when I ran one variable statistics. So I can press the variables button. Again, I'll go down to option 5. That is the statistics option. Press enter. The standard deviation you can see is option 3. Press enter. And then I'm going to store this into list 2. Store, second button, 2. So with one command, I'm going to generate all of the z-scores for all 28 observations. So if I press the stat button and enter, I can go see all of those. So these are all of the values that are below the mean, so they should have negative z-scores. Then if we scroll down to the bottom, we will get to the higher scores that are above the mean. They will have positive z-scores. There they are. So at this point, though, what I'm interested in showing you is that the mean is really 0 and the standard deviation really is 1. And in order to do that, I'm going to go back to the home screen, second, mode button to quit. I'm going to press second and the stat button. That will take me to my list operations. I'm going to go over to math. And I'm going to select option number 3, that is the mean, and press enter. And I'm going to take the mean of list 2, that's where my z-scores are. And indeed, the mean is 0. Again, if you had entered 78.9 for the mean and 13.5 for the standard deviation, you'll get close to 0, but I doubt it would be exactly 0. So in terms of the standard deviation, I claim it should be 1. Let's take a look. Second, stat button, again, we'll go to our list operations. We'll go over to math. Standard deviation is right there. It's option number 7. So I will choose option number 7. You could just press the number 7. I'm just taking my time. And I'm going to calculate the standard deviation of that second list also. And that should give me 1. And indeed it does. There we go. So last, we have calculated the z-scores in list 2 for all 28 exam scores, and now we can use those to answer a few simple questions. So an A required being more than about how many standard deviations above the mean. So recognize what the z-score does. It tells me how many standard deviations observations are from the mean. So let's go take a look. I'm interested in how many standard deviations away from the mean I need to be in order to get an A. So let's take a look. Press stat and enter, and I'll go in. So a little trick, if I want to scroll to the very bottom of the list, I can actually press the up arrow and it will take me to the bottom of the list. So here we go. I guess part of the problem is you have to interpret what we mean by A. Do you want to include the A minuses? So the B plus, that was at 0.67 standard deviations above the mean. The A minus required 0.82 standard deviations above the mean. So to get an A, we needed to be just a little bit past 1 standard deviation above the mean. So I'm going to interpret this question a little bit more loosely. So any type of A, including the A minuses, we needed to be a little bit more than 0.8 standard deviations above the mean. There we go. So, and again, it's about. So an A required being more than about 0.8 standard deviations above the mean. Fair enough. If you want strictly A's, not including the A minuses, you could have said more than about 1 standard deviation above the mean. Fair enough. So z-scores between -1 and 0 account for grades of what and what. So let's go look at these z-scores and see what grades those correspond to between -1 and 0. Now let's go take a look here. So I'm going to have to go back down here. 0. Notice a z-score pretty close to 0 is at C plus 79. So I'll continue down. Let's see where my -1 is. Getting close. Oh, I passed it. Forgive me. There's -1 right there. Oh, look at that. A D, 67 was at -0.88. An F at 63 was at -1.18 approximately. So roughly speaking, at -1, that's approximately the cutoff point between passing and not passing. And 0, if we scroll up a little bit, get back to our z-score of 0, again, for this test, that is roughly, here it is, roughly that's the cutoff, not quite, but it's roughly the cutoff between B's and C's. So roughly speaking then, z-scores between -1 and 0, they account for all, I'll put that in quotes, so we're just speaking roughly here, all of the grades of, it looks like D and C. So the idea here is we can use z-scores to interpret what we see within the distribution. We can also use z-scores in order to compare observations from completely different distributions. All of these are very useful skills. We will use these for the rest of AP statistics. Hope this has been helpful.